Okay, let's take a look at this quiz here. We got a 6-volt battery with an internal resistance connected to two resistors that appear to be in parallel with each other. So the first thing we might do here is sort of simplify this circuit a little bit to find out how much current's flowing. So we could redraw it like this without meters, and we can see that these two are in parallel with each other. So I can do the reciprocal of sum of the reciprocal with each of those, and we will turn that or simplify that into 3.4 ohms. And then we could redraw it one more time, and that might be useful. We'll call that the virtual circuit, which is just purely series, and then the total resistance would be 4.6. Then from that we can figure out how much current flows in this virtual circuit using Ohm's law, V over R. In this case then the V would be 6 and the R would be 4.6, and the total current that flows would be 1.3 amps. 1.3 amps. So that would be the current flowing around this circuit here. Now, the voltmeter that is in the diagram up here, if we were to draw that into the circuit, the virtual circuit, that voltmeter would be right here. So this voltmeter is reading what this voltmeter reads right here. Now, those two things are in parallel. If I put a voltmeter right here and I put a voltmeter right here, those two things would be reading the same thing. I could also put a voltmeter over here on this little resistor here, and if I do that into the virtual circuit, that would be this voltage. All right, now I could figure out what these voltages are doing I times R, like that, whereas I, in this case, is the 1.3, and the R, though, is this 3.4. So the voltage across that part, the parallel part of the circuit, would be 4.4. Now, the rest of it, now remember, this is a voltage divider, and this is 6 volts here, and that's going to get split up between the two. So I could say 6 minus 4.4 would tell me how much this one is here, or I could do I times R for this one as well and figure out what that is. And the I, again, would be the 1.3, but in this case, the R is 1.2. All right, so 6.6 minus 4.4 is 1.6, and 1.3 times 1.2 equals 1.6. 1.6. All right, so it's a voltage divider. Now, the voltmeter up here is the same as this one, or this one, or this one. So what does the voltmeter read? That should read 4.4 volts. 4.4 volts. Okay, number 2. What does the ammeter read? Now, the ammeter in the circuit, in the main circuit, is right there. In this circuit right here, and in this circuit, it's kind of hidden in this branch right here. All right, so we want to find out what that ammeter reads. We could do I equals V over R. Now, the V would be this voltmeter and this 8 ohms, that 8 ohms. So we can figure out what that current is right there by doing V over R, and the V is going to be 4.4, and the R now is just the 8. So this ammeter will read 0.55 amps. All right, now the main current is 1.3. So if 5.5 is flowing there, then we could just subtract and get how much current is flowing there. They don't really ask us what the current is through the 6 ohm resistor, but we could figure it the same way, because the I here is going to be V over R. Now in this case, V is 4.4, but the R is only 6. So how much current is flowing in that part of it? 0.73. Now the 0.73 plus the 0.55 should add up to the 1.3, and it would, except for a little bit of rounding probably on there. All right, number 3. What is the power dissipated by R2? R2. Now, we could figure this a number of different ways. We could calculate it using P equals V squared over R, in which case the power would be 4.4 squared divided by just the R of 6 ohms. That would give 3.2 watts. 3.2 watts. Now, another way to calculate it would be to go P equals I squared times R, and the I in that case is that 0.73 times that R of 6 ohms would give us 3.2 watts. 3.2 watts. So we could calculate it that way. A third one would be P equals V times I. V times I. In this case, the V would be across the 6 ohm, which we determined to be 4.4. And the current we figured out was 0.73. So in doing it this way, the power would be 3.2 watts. 3.2 watts. So we could calculate the power in a number of different ways. Okay, there we are.